Welcome back everyone to Data Science for Everyone. Today we're going to be talking about linear regression with PySpark. Let's get started. When we use Spark data frames, particularly when we're using machine learning in PySpark, we're going to be having a bit of special cases in the way that the data needs to be shaped. So we'll take our time when we're talking about data transformation and what steps we need to take to get it into that format. So let's start off with our basic imports. So from PySpark, SQL, import Spark session. And then we're going to start a Spark session with our builder. And we're going to give it an app name of a linear regression example. And we're going to get or create. And then we're also going to just start out from PySpark .ml for machine learning, dot regression, import linear regression. So those of you that are familiar with using my brain's a little tired today. Using scikit-learn, that type of stuff, it's very, very simple to get used to that. Now, I'm just going to pull up this data set that I've downloaded here. This is from their GitHub page. You can see here Apache Spark. So this is their example data. I'm going to just call this training for now. We will go back and I'll show you how to use train test split in a little while, but right now I want to just deal with the data in this way. Now we are using what's called a libSVM. Now we haven't really seen this before, but the reason their examples are using this type of data is because of the way that their backend works for loading data. So when we get data in the future, we will need to create it and kind of move it into this libSVM. And whoops, what happened? Let me see here. Yeah, I want this. Oh, it's because I misspelled it. See. Now, and I will show you what I mean here in a second by this. It's a very interesting format, to say the least. What happened here? Uh-oh. Hold on. Let me see what's going on to it. Now that we fixed the issue. So let's take a look at the training data itself. You can do .show here. And we see that we have two separate columns now. Now this is definitely different than what we are used to seeing. Now we have a column for label and a column for features. Now if we look here, there is this very interesting looking format here. We see here that there's a label and then it has this 10 comma and then it looks like it has a list object in here. What's actually going on is basically this is a compressed matrix. This is. So it's a 10 by X, 10 by N matrix of some sort, and then it has each of the labels. And so you're using all of this data here to predict this label, all of this data here to predict this label here. And usually you would have something along the lines of maybe where y is equal to some vector here. So for y1 to yn, and that would be this here. That's our y. And then we would usually have our features here, which is some matrix x, where it's something like x1 to x1m, and then something like x n1 to x in M. So where this is a square matrix here. And so that's this one here. But what we're doing is we're pushing all of these into these little formats here where it's telling us what everything is. And this is just the way that we will eventually have to convert all of our data to when we want to run regression models with PySpark. So let's go on to the next part about this. Okay, again, it's going to expect, and let me just say this again, all of the models are going to expect it to be labeled like this. The labels are your targets, okay, and then you have your features. This is required here. We expect all of this to look like this, okay? This needs to be numerical, okay, for regression type classifications, okay? And it also still needs to have a numerical value that would match up to a classification when we do classification. So you can't just leave this as the text. We will have to do conversion later on to some sort of numerical format. And then the features, again, is going to be inside of a vector. And that, again, that's going to be this nice long row here. Now we will do this by usually combining features from our columns. Again, remember we have our matrix. So let's move on to the rest of the example now that I just reviewed that one more time. So let's instantiate the model, linear regression. Now here though, unlike in other instances, when we do this, we actually have to have our feature columns. And so here we actually will call this features. And then we have our label column, which we are going to call label. And then we would also potentially have something like what we want our output to be. And so in this instance, we would have our prediction column here. And we'll call that prediction. So then we run this. Again, there are a lot of, we also have potentially other parameters in here for normalization, regularization, that type of stuff. And we'll talk about that later on, and we can always check the documentation whenever we need to. So let's have our linear, and we'll just call this our actual model here. So we do lr.fit_training. And we're going to run this. And again, I know that I didn't split this data yet. We are going to run it, again, we're doing a bunch of a faux pas here, but we are running it on the a full set of the training data, all of our training data, and then we'll actually go about and give it a try to see what we have. Now from our linear model, we can actually go about and grab the coefficients and run this, and it comes out as a dense vector. So if we want to convert this to something that we can kind of read, we need to actually wrap it in the stir function. Okay, and notice here now it gives it out as kind of like a list type object. And then we can maybe do something like print coefficients, whoops. And then we'll add in our stir here. And let's also go about doing the intercept. And we'll talk about other means of doing this as well later on in our series, but right now it's not really of importance. I just want to get through running the model once. So if we run this now we get a nice looking coefficients, but again, it's in this nice list object, and again, it's pretty long. There's going to be 10 of them here, and then we also have our intercept. Now, there is a summary attribute that contains a lot of information. So let's create a train summary and do something like lr model dot summary. And again, notice if I just run this, it actually just spits out a summary object here. So that's not going to do us any good. We actually have to use some attributes and grab attributes from it. So for example, if we wanted to grab the mean squared error, we can grab the mean squared error. Okay, and we can also grab, for example, train summary dot root mean squared error. And then we can also do something like even training summary dot r squared, and we even have the adjusted r squared. So if we wanted to make this look nice, we could do something like print, and let's do MSE train summary dot mean, and let's just do everything like we have been in the past for our other series. So let's do also the MSE here. Oops. Train summary, and then we want here the mean absolute error, mean squared error here. Why are you not wanting to autofill for me? There we go. And then print here RMSE, and then we will do train summary dot root mean squared error. Now, there is something that I would like to say on this, is that there have been some changes to the way that we fill these out. This all used to be caps, so it used to be mean with a capital E, so this has changed. So just know that in older versions there is a breaking issue here, and just keep that in mind. There we go, and I want the adjusted. So now whenever we print this out, it'll look relatively nice and pretty for us here. And we can see that this is absolutely a terrible model. But again, that's what we expect with just some randomized data. Let me see how much time we have left. Okay, we got plenty of time. So now we'll go back and we will correct our big error here. Okay, this is just a full training data. We did not do any train test splits. We didn't split any of the data. So let's make sure and go about and fix that. So let's go with okay, this is literally going to be one of the easiest things that you've kind of ever done or seen, compared to a lot of other ways to split data with other types. So let's just call this df for now, and I'm going to re-import the data so that I actually have a new copy. And this is all of the data. This is all data. This is the full data. This is the full data set. Now, we are able to pass in data. So let's do something like train data and test data. And then this is going to be our df dot, and here we just do random split. And then we give it a list of two objects here. So I want to do it as 70 and as 30. So let me grab here how I want to actually put my notes in here so you guys can read this. So we're going to pass in this data to a train test split. Again, it's as a list. Now, there's no real correct way to do this. Some people do 80-20, some do 70-30, some do 60-40. Just right now, I happen to be doing, whoops, and that's a dot, 70-30. And again, depending on how much data you have and how unbalanced it is. So We'll be talking about unbalanced classes and that type of stuff later on in the series, but right now we should just go about doing this way. And there should be a seed here, okay? And so I want to set a seed, and I'm going to set mine, as always, to 42. And so this way, again, everything that I do and you do is going to look identical. I would highly suggest that you guys get accustomed to setting your seeds. So if we take a look at our data, and remember now we're going to start only looking at our training data. We're not going to be doing any data snooping. And my internet connection is still wonky today. So again, you can see here that we are in this format. If we took a look at the, you know what, okay, we can do a little bit of data snooping today. Well, let me, because I want to show you, for example, what this data looks like. Because again, here notice it is now, it's still in the correct format, but if I go back and I check our test data, it is also going to be in that correct format as well. So let's go about actually setting up our, we want to grab our unlabeled data. So let's do unlabeled data is test data. And I want to select out the features. Okay, and again, just showing you guys that's this here, features. And I'm grabbing it from the test data. And again, the reason I'm splitting this out is because technically we have the labels for our features here. Okay, but again, since we're just making up our own test data, we have to be able to split them apart. Now let's actually, we only are going to train on the training data. So let's call this, let's call it, yeah, let's just call it the correct model or corrected model. Okay, since before we were just doing it on all of the training data, we want to make sure that this one has its own. So let's do a fit. And we are going to do this on train data. And you know what? Let me talk about this one more time here. Usually, like if we were using sklearn or something else, we have to split the data up as this xtrain, comma ytrain. When doing this, when doing fit here, but because our data is already in this type of instance here, okay, with the labels and the features, we don't have to do that because it actually has our X. It has our X here and it has our Y here already built in. And that's kind of the beauty of this, is that there's just kind of one less step to take care of. So let's fit the model. And then let's make sure and evaluate the model. So let's do our test results, or you know, I'm just going to call this results, res, here, and then our corrected model dot evaluate here, and then we have our test data. Okay, now we have our res, and then now we can actually go about looking at the results. So let's do res dot, oh, you know what? Let me go and I'm just going to copy this nice piece here. Eventually we need to make this into a function so that we can make this nice and easy to do. And instead of train, we do res. And hopefully there's no breaking in here since we used evaluate instead of the summary function. All right, and so then now we have all of our results here. They are different than what we had before, okay, because we did do train test split. We also see that our model is still no good. But again, that's what we're going to expect with completely randomized data. Again, it's not going to have such great predictive accuracy. Now let's actually transform our data because again, it's not, again, we were going to want to test this data against our unlabeled data. So we need to actually build a model that does that in the first place. So let's grab our predictions. And so here we're going to do is our equal to, and we have our corrected model dot transform. And then we are going to give it our unlabeled data. And then here we can do predictions.show, and this will actually show our predictions here. Now, again, later on we will want to do some plotting and everything to be able to do some visualizations on this, but for right now I just want to be able to run everything together so that we can see how for example, what our features look like with their predicted labels. And so, as always, thank you guys very much for tuning in. If you guys liked it, please comment and subscribe, and I will see you guys later. Bye-bye.